Hi, this is Mathematics for Social Justice by Bertrand. Today, I want to see a connection between the harmonic mean, which we've discussed in the past, and a new topic, for me, Bertrand's Ballot Theorem. So, the harmonic mean has these formulas. Or for the harmonic mean of two numbers A and B. I want to introduce a couple of new formulas. One is H equals A plus A times B minus A over B plus A, or H equals B minus B times B minus A over B plus A. So this refers to a discovery I made earlier. If you want to find the harmonic mean of 2 and 6, break this space into 2 plus 6 spaces. So it's been broken into 8 spaces. And H is 2 spaces over because that's 2. So because that's 2, you go 2 spaces over for H. So this is basically saying start at A, this is how long each space is, and go that many spaces over to the right. Or you can start at B and go B spaces left. So this is 6, you go backwards 1, 2, 3, 4, 5, 6. Or again, you can start here and go 1, 2. So these numbers tell you how far to move. Just make sure, if this is 2 and 6, that you've got a total of 2 plus 6 spaces. So this right here is a harmonic mean. It turns out each space is 1/2, so this will be 3. Now when you go from 2 to 3, you get the same percent increase as the absolute value of your percent decrease going from 6 down to 3. So if you go from 2 to 3, that's a 50% increase. And when you go from 6 down to 3, that's a 50% decrease. Let's just verify that again with these formulas. So the percent increase is change over the old equals blank per 100. So when you go from A to this is your old and this is your change. Okay, so the change would be A, B minus A over B plus A, over your old, which is A. And then your A's cancel. So when you go from 2 to 3, that's B minus A over B plus A. That's 6 minus 2. 6 minus 2 over 6 plus 2 equals 4 over 8, which is a 50% increase. And when you go down, this is the change and this is the old. So again, it's going to be the same thing. You're going to get B times B minus A over B plus A over B. You end up with the same ratio, so you're going to get the same fraction, except one is positive and one is negative. So when you change that to, in both cases you get a positive fraction, but it's a decrease, which is negative, of course, and it's an increase, but the absolute values are the same. What's so special about the harmonic mean again? Well, if we find the arithmetic mean, then the arithmetic mean times the harmonic mean is equal to the left side times the right side. Another way to specify what the harmonic mean is to look at this distance and look at this distance. And the ratio of the distances is 3 to 1. Now compare that to the ratio 6 to 2. It's the same ratio. So that's another way to define the harmonic mean. So now we're going to introduce Bertrand's Ballot Theorem. And Bertrand's Ballot Theorem is usually about voting. You have two candidates. Let's call them D and M. And let's go ahead and give them names. So let's talk about Deba and Mark. And they're in an election, and Deba gets 2 votes and Mark gets 6. Okay? And we want to know what's the probability that Mark's vote total, as the votes were being counted, was always strictly ahead of Deba's vote total. And it turns out the same ratio, B minus A over B plus A, that's equal to the percent, which we know is already 50%. There's a 50% chance that Mark's vote total will always be ahead of Deba's votes total if Mark gets 6 votes and Deba gets 2. Okay? So now let's go ahead, instead of talking about votes, let's talk about a walk. So suppose Deba starts here and Mark starts here. And Deba's going to take 2 steps. You see, Deba and Mark are stuck on the number line, but they can move on the number line. So Deba can move 2 steps towards Mark. Mark can move 6 steps towards Deba, and they can meet at H. Okay? Now, we're going to try to calculate the odds that Mark's steps are always strictly greater than Deba's steps in total. So if Mark takes the first step, that's fine. But then Deba can't take the second step because then they both have taken 1 step. And we want Mark's steps to always be strictly greater than Deba's steps. So we have to start with 2 M's, which means Mark takes the first 2 steps. And then Deba can take the 3rd step, or Mark can take the 3rd step. But when you're all done, you have something like possibly so that's 8 steps, and Deba took 2 of them. And Mark's steps were always strictly greater than Deba's steps. And the claim is the same ratio that we use in the harmonic mean will tell you the probability that when you take all these possible paths, that Mark's steps are always strictly greater than Deba's steps. To find out how many ways you can write these, it's just 8 choose 2. Because out of the 8 places, Deba could theoretically be 2 out of 8 spaces, even though before we disallow any possibilities. So that would be 8 times 7 divided by 2 times 1, which would be 28. So there'd be 28 ways to make these lists. But 50% of them would be bad if we say Deba took a step too soon, because we want Mark's steps to always be strictly greater than the number of Deba's steps. So we want to try to prove that. Well, if you compare 2 and 6, 2 is 1/4 of the possible 8 steps. And if you change that to percent, that's 25%. And we're not going through all the probability arguments. If you made a list of all the possible strings like this, Deba would be the first letter 25% of the time. If you made a list of all 28 possible lists, 25% would start with a D. Okay? We're calling all those bad lists, okay? So let's look at other bad lists. So for example, if you had Mark and then Diba, and you want to finish that list, there's 6 more spaces, right? And Diba could be any one of these 6. So that would give you 6 possibilities. The other possibility is you have 2 Marks and then 2 Dibas. That would also be bad because Diba would be tying Mark, and that's not supposed to happen. So you would have 6 of these, where Diba would be one of these places, or one of these, where 2 Dibas follow 2 Marks. So these are the 7 things that can happen when Diba is not first. Well, how many ways can happen if Diba is first? Well, in all these cases, you just switch these 2. So you would switch MD to DM, and then whatever follows. And here, you would switch all 4. So you would take it and go DD, MM. Let's review what we have so far. We have 28 lists. 7 are bad because they start with D. And 7 are bad because they start with M. Now, why did that happen again? Because you can take any of these 6 bad lists and switch this M and this D. Or you can take this bad list and switch MMDD to DDMM. So you start with 7 bad lists, and then you get 7 more bad lists, which is 50%. So out of the possible 28 lists, 50% are bad. And you can think about it like this. You have to start with 100% of the lists, and then you subtract 25%, and you subtract 25% again. So altogether, 50% of the 28 lists are bad. So to review, why is this 25%? Because if you look at the string, D is 2 out of 8 letters. So 2 out of 8 is 1/4, that's 25%. So since you have 25% of the letters being D, you can make a probability argument that when you make all the lists, that D would start 25 of all the possible lists. And you want to subtract those. But you also want to subtract the same number again, because every time you have something that starts with DM, you can make a switch and switch a DM beginning to an MD beginning. So you're actually subtracting 25% twice, which is 50%. Now, the next question is, what does that have to do with B minus A over B plus A? Well, 100% is B plus A over B plus A. Okay? So again, B is the number of steps that Mark takes, and A is the number of steps that Diba takes. So this, now if we subtract 25%, we're subtracting A over B plus A. We're subtracting Diba's 2 over Diba and Mark, which is 8. So subtracting 1/4. And then we're doing it again. But if you just look at this, it's equal to B minus A over B plus A. What I've tried to do in this video is show you a connection between the harmonic mean and Bertrand's Ballot Theorem. So thank you for watching.